Hello guys, this is Virender Singh and welcome back at Mastercam Multiaxis tutorials and Toolpath. Mastercam previous few of in Multiaxis series we are discuss about the basics concept of the Multiaxis, what kind of the toolpath we have to use, the tool axis control and something different. And in this video we discuss about that how we can create a Swarf toolpath with the help of any kind of model. So before starting the learning of the Swarf toolpath, I would like to show you one of the simulations which is using with the help of Swarf toolpath. So let me start this video. So as you can see with this video, Swarf toolpath is that kind of toolpath where we cutting with the complete fluid area of my tool, where the tool automatically decided that where that have to be cut, and tool will be automatically tilting according to the surface area, and tool will cut with the help of complete fluid length. So we will discuss about the toolpath parameter, and step by step we will learn about the detail about that one strategy. So Swarf toolpath is one of the toolpath which is using mostly in a Mastercam multi-axis. So this is the complete toolpath which is created with the help of Swarf toolpath. So now we have to come on the Mastercam screen, and step by step let me discuss about the all parameters of the Swarf toolpath. So for creating a new toolpath with the help of Swarf one, we have to just delete everything and just say OK. Now let me start with the new toolpath. So for creating a Swarf toolpath, we have to come on Mastercam multi-axis toolpath. We have to click here, and this is my Swarf milling. Once we click on a Swarf milling, so that time Mastercam will automatically bring a new window with the Swarf toolpath parameters. Now first step that we have to select a tool which we have to use for cutting purpose. So for that time we have to go in a library, and we are just using 12 mm of tool. And once we choose a tool, we have to double click on a tool. The one of the most important thing, then one parameter which we have to make sure in a Swarf toolpath we are using cutting with the help of fluid. So your fluid length should be large in more length as compared to contacting of the surface. So we are just created 70 mm. This is my cutting length of my tool. Now just say finish. In a next step we have to came on the cutting parameter. Now at a cutting parameter, what we have to do? In a Swarf toolpath, in a cutting parameter, first step that we have to click the surface where we have to cutting. So this is the Swarf geometry. We have to just click it here, and we have to select a Swarf surface, this one, and this one. Now we are selecting all the outer area for this one component, and now we just say OK and just OK. So now as you can see here, my Swarf toolpath will be created with the help of all these kind of surfaces. Now let me run this toolpath. So my tool is starting to cut from the upper portion to the bottom portion, and tool automatically tilting their axis as per the surface. So this is the method we are using the Swarf toolpath. Now let me discuss about the Swarf toolpath in detail. So creating a Swarf toolpath, we have to make multiple controls, and we have to know about the all the parameters of Swarf toolpath. So let me discuss about the step by step. So for creating a Swarf toolpath, the minimum parameter which we have to choose, that is called a Swarf geometry or a surface, where tool have to be run with the contacting of this one. If you choosing that's in the only surface, so that case your toolpath can be created. If we came to the next parameter, this is my float geometry. Here the float geometry means you have to select a bottom geometry. If you want to avoidance or something like that, that my tool don't have to be penetrate on that surface, so we can select a Swarf geometry where tool will going to be bottom will going to be limited. That tool will not going to be touch the bottom geometry. At here Swarf clearance, it means if you want to make some stock at the surface where the tool have to be run, so you can define the Swarf clearance. In the next parameter, this is called tilting line. What is the meaning of tilting line? We will discuss on the next step. Now we have to come on the guide curve. Guide curve means if my tool have to be run with this surface, so we have to define the upper rail and the lower rail. Both of these rails will be control my Swarf tool path. So let we have to come about touch here the upper rail and lower rail. At the upper rail we have to select with the surface this one. The upper rail, this is the upper rail. Tool have to be start from this portion to this portion. Continue with the red this one, continue with the red this one. So this is my upper rail. My tool have to be start from this to this one. Now at the lower rail means the my surface bottom edge. We have to select this one, continue with this one, continue with this, and from starting to that one to the end of this one point. So this is my lower rail. So you can, when you are sometime when you creating a tool path and your tool path will not going to be running with the proper finishing, so that time you can define upper rail and bottom rail. So what will be the benefit with this one? When we are defining the guide curve, so our tool path will guiding in a proper way and your tool will be much smoother than the earlier. So this is the defining, we are defining the upper rail and the lower rail. And the second important thing that we have to define for the upper rail and guide lower rail, that is when you are defining the upper rail, it means that tool have to be coming from this one direction and tool bottom portion should be this. If we are just make the swarf, what will happening? Tool will, upper rail will going to be changed to the lower and lower rail will going to be changed with the upper. Look at this one. So at here, as you can see this, my tool will going to be entering from the down portion, and the reason behind that, because I just change my upper rail to the lower and lower rail to be upper. So make sure when you are selecting upper rail and lower rail should be that one where tool have to be coming from the upper direction, and lower rail should be that your tool bottom edge should be located. So if you are not selecting in a proper way, you can click at the swarf and you can convert in from upper to bottom, upper to lower, and lower to upper. Now in the next step, let me discuss about the tilting line. At here, tilting line, it means some of these lines which are connecting with the upper rail and the lower rail. If sometimes my tool is not going in a proper way, so we can defining our guide curve, and make sure you have to defining the guide curve from bottom to the upper. So let me defining a guide curve. So for defining a guide curve, make sure you have a guide curve. So for creating a guide curve, you have to come in a wireframe, curve on edge, and you have to select a curvature on my surface. I have to come on next, again parameter, I select tilt line, so let me check again. I have to came on a curve, parameter. Make sure if your line, the guideline which, if my guideline is not connecting between upper rail and a guide rail properly, so that will going to be not going to be selected. So make sure this is the one of the important thing that you have to mention at here. So the guide rail is not connected, selected. The reason behind that all these guide rails are not properly connected with the upper rail and the lower rail. In the next step, let me discuss about the machining orientation. Machining orientation means you have to defining always tool plane. Tool plane, it means that Swarf milling tool path automatically selected tool plane according to the surface. In the next step, we have to define the side. Sometimes we have to controlling with the sides, and when we are selecting, for example, left side, it means, look at this. My tool is starting to cut from the inner portion of this surface, and that we can control with the help of left to the right and right to the left, and that is we are controlling from the side. If we are selecting the right, so what is happening? My side is going to be changed from the right to left and left to the right. And this is something we are using. Look at this. This is also right. Last time my tool was starting from the upper, now tool is starting from the bottom. I just select left. Left means now my tool will cutting the outer portion. So this is the method we have to use when we are using the side. And there are some methods are also available when we have close area, so we can define the inside, outside, front side, back side. There are multiple options we can use, and most of the time we have to select auto detect. Auto detect means software automatically calculated from the as per read the model, and according to that tool path will be created. So this is the best way or the best method we have when we are selecting this the side tilt. In the next step, now we have to defining the direction. Sometimes now, as you can see here, my tool is start to cut at the outer portion, it means the left side, but tool is starting to cut from upper to the bottom. But in any condition, I need that my tool have to be starting from the bottom portion to the upper portion. So that case you can change conventional to the clamp. So now what is happening? My tool path will going to be starting to the cut from bottom portion to the upper portion. It is still cutting the outer side. So this is the something like as orientation which we have to say that which kind of tool path you have to choose, clamp milling or conventional milling, up milling or down milling. In at here guide curve at it means that how you have to guiding your tool path. Now we are mostly select the lower curve. At here you can defining the start point. There are multiple options available at the starting point. You can define the exact, you can say automatic, you can define the 2 points, you can define the tilt line, as well as you can directly define a point that my tool path have to be starting from the particular that one area. The starting point is working where we are using something like as closed area or a closed surface. So that case you can define the starting point. When we are using an open area, so tool have to be starting from the left to the right or right to the left. In next step there is something more parameter that is called advanced control. In advanced control you have to define the strategy that how my tool have to be running. So make sure you have to choose always automatic, and at here extension type. At here in extension type you have to define that how if my tool surface is going to be close at here, but I want that my tool have to become some outer side. So that case in the this one is if there is chips or some extra material that can cut and clean easily. So that case you can define some extension length, and that extension length I just define that 100 at the starting, 10 at the starting and 20 at the exit, 15 at the exit. So you can define as the parameter as you want. And the next one of the important is cut tolerance. If you are creating a tool path as the starting, it will take more time. You can say 0.1 or something 0.1. So that case your tool path regenerating time will automatically going to be less. So look at this, my tool is starting to cut more outer as compared to the previous one, and all these the reason behind that we are using this one, the extension. So if required you can define the extension. It helps more many times. You can define the extension, it will come, tool will going to become from the outer of my surface, and again when it's completely cut, so it will going more than from this one length. In the next parameter, this is the my cutting parameter page. If we have to came on the next parameter, and if you have any doubt on a particular any parameter in a cutting parameter, you can ask the question, you can comment at our video. In the next step that we have to come on the tool axis control. At the tool axis control, you can define the 4-axis tool path, 3-axis, or 4-axis, 5-axis, or 3-axis. Generally, we in the Swarf milling we are mostly trying to use with the 5-axis tool path. If you are using with the 4-axis tool, if you are using 5-axis tool path, so make sure your A, B, and C from 3 of 2 chord to NC and NC output, 2 things will become A or C, A or B, or A, B or C. But if you want that my tool have to become in a 4-axis only, so you have to define the 4-axis and in which axis my rotary have to be rotated. So you have to define with the X, with the Y, or with the Z. So according to the define, my next axis will be add-on. So make sure you have to check properly that what kind of machine you have and what kind of project you have. So mostly if you have 5-axis machine, choose the 5-axis. If you have 4-axis machine with the rotary table, so according to that you have to choose. In the next step, we have to came the Gauss control. At here, this is the Gauss control page where we have to controlling the gaussing, or this is also known as when we have getting some accident, so how that time my tool path will going to be reacted. So make sure you have to choose Gauss control, Gauss curve, guide curve only, or we can defining the Swarf geometry. So that all the parameters you have to make sure as currently now, because Mastercam automatically providing the default parameter as the best, so there is nothing to you have to define, defining or selecting. In the next step that we have to come on the linking parameter. At the linking parameter, we will create a separate video where we will discuss about all the detail about the linking parameter. At here, we have to came on the multi-axis cut. As you can see here, my tool path is created, but it's cut in a single pass or a single cut. So at here, we can defining with the multi steps. I just say multi steps, 3 steps. So what is happening? My tool will create it with the multiple step, and this is created with the help of total 3 steps. First, second, this is the 3. So according to the total length area and according to total workpiece, we can define the depth of cut with this one method. At here, now we have to came at here. So what is happening? My tool path is created, but each time it's came in a one way. Again, it's going at the starting point. So you can define the zigzag. What is the benefit with the defining of zigzag? When we are creating with the multiple passes, each time so my tool have to become starting from this one, again start complete at here. For the next part is starting from this in the next step. So it will, your linking parameter and lifting will be going to be less. If you still your linking will be there, you have to came on a linking parameter, you have to say direct. And large Gauss is also direct. So as you can see here, this is the best method to create a Swarf milling tool path. This is starting from the bottom to the upper. At tool is finishing at here. Tool automatically take depth at this one portion. Again going at the bottom. At the bottom it take again the depth and it's came at the upper area. And we are defining total number of 3 passes and it's complete successfully. At here, if we want to make at the multi-axis cuts, if we want that my material is much higher, or in a much which we want to make multiple passes in that kind of, so we can also define that my multiple passes should be 2, and you can define the step over value, that is I make 5. So we can also define that value. So according to that, my tool path will be running as the parameter we are defining. So at here, as you can see, my tool is starting to cut first the outer portion. It's complete 3 passes, and now it's came to the inner area. So this is the method that you can defining the Swarf tool path with the multiple options, and you can cut your material according to your profile with the help of only selecting with the surface area. So this is all about the surface tool path. In the next videos we will discuss about some of the more toolpaths. I hope you guys learn all about the Swarf milling toolpath. So see you in the next video. Bye bye.